we learned the definition of sine, cosine, and tangent theta in a right-angled triangle. Sine theta is opposite side over hypotenuse. It is A over C. Cosine theta is adjacent side over hypotenuse. That is B over C. Tangent theta is opposite side over adjacent side. It is. However, this definition can only be used in right-angled triangle. If the triangle doesn't have 90 degrees, we can't use this definition to solve the angle or find the length of one side of a triangle. Therefore, if the triangle doesn't have 90 degrees, we need another formula to solve the angle or find the length of one side of the triangle. That is the reason why you need to learn the sine formula. In sine formula, we use the capital letters A, B, C to represent the angles. The small letters A, B, C represents the length of one side of the triangle, where the small letter A is the opposite side of the capital letter A, small letter B is the opposite side of the capital letter B, and small letter C is the opposite side of the capital letter C. In sine formula, sine A over A is equal to sine B over B is equal to sine C over C. Next, I'm going to explain why we have the sine formula. We draw a perpendicular line from C to AB and meet at D. In triangle ACD, sine A is equal to CD over B, so CD is B times sine A. In triangle BCD, sine B is equal to CD over A, so CD is A times sine B. So we have B sine A is equal to A sine B. Rearrange the terms, we have sine A over A equal sine B over B. So we prove the first half of the formula. Now we prove the second half of the formula. We draw a perpendicular line from A to BC and meet at E. In triangle ABE, sine B is equal to AE over C. So AE is equal to C times sine B. In triangle ACE, sine C is equal to AE over B. So AE is also equal to B times sine C. So we have C sine B is equal to B sine C. Rearrange the terms, we have sine B over B is equal to sine C over C. Then we prove the second half of the formula. As both formula has sine B over B, we can combine it into one formula, that is sine A over A equals sine B over B equals sine C over C. From this explanation, I hope you learn more and understand more about the sine formula. In this example, I will tell you under which given condition you can use the sine formula and how to use the sine formula. Firstly, we can use the sine formula when the question is given two sides and one angle, and the angle is not included in two given sides. Under this given condition, we can find angles in this triangle. So in part A, to find theta, we notice that AB is opposite to the angle theta, and BC is opposite to the angle 105 degrees. So we have sine theta over 6 is equal to sine 105 degrees over 7. Then sine theta is equal to 6 times sine 105 degrees over 7. We can use the calculator, shift sine. You can find the angle 55.9 degrees, correct to 3 significant figures. After we calculate the theta, we can use angle sum of triangle to find angle ABC, that is 180 degrees minus 105 degrees minus 55.9 degrees. The answer is 19.1 degree, correct to 3 significant figures. Secondly, we can also use the sine formula when it is given any two angles and one side in the triangle. When we have this given information, we can find the remaining two sides of the triangle. For example, in part B, we can find angle ABC first. We have 180 degree minus 75 degree minus 37 degree. It is equal to 68 degree. Now AB is the opposite side of angle C, and AC is the opposite side of angle B. Using the sine formula, sine 37 degree over x is equal to sine 68 degree over 5. So x is equal to 5 times sine 37 degree over sine 68. So x is equal to 3.25, correct to 3 significant figures. We can also use the sine formula to find BC. Notice that BC is the opposite side of 75 degree, and AC is the opposite side of angle B. By sine formula, sine 75 degree over BC is equal to sine 68 degree over 5. So BC is equal to 5 times 75 degree over sine 68. The answer is 5.21, correct to 3 significant figures. Let's go through some examples. In this example, you need to find the lengths of AB and AD. We can find AB first, because in triangle ABC, AB is the opposite side of angle C, and AC is the opposite side of angle B. So in triangle ABC, by the sine formula, sine 40 degree over AB is equal to sine 55 degree over 8. So AB is 8 times sine 40 degree over sine 55. So AB is 6.277590239. It is 6.28 cm, correct to 3 significant figures. After we find AB, we can find AD, because in triangle ABD, AD is the opposite side of angle B, and AB is the opposite side of angle ADB. So in triangle ABD, angle ADB is 180 degree minus 45 degree minus 55 degree. It is equal to 80 degree. By sine formula, sine 55 degree over AD is equal to sine 80 degree over 6.277590239. So AD is 6.277590239 times sine 55 degree over sine 80 degree. We have 5.22 cm, correct the answer to 3 significant figures. Pay attention, if we need to use the previous result to do the calculations, we need to use a more accurate number, and that is the number with more decimal places. If you use the number corrected to 3 significant figures to do the calculations, sometimes you will get an inaccurate result. As a result, you will lose the answer mark in your tests or the final examination. Therefore, you should always use a more accurate number to do the calculations. Next, we are going to find the theta in this parallelogram ABCD. Since AD is parallel to BC, angle DBC is equal to theta. Besides, in a parallelogram, the opposite sides are equal, so CD is equal to BA is equal to 9 cm. As you see, in triangle BCD, we have two sides and one angle, 97 degrees. We can use the sine formula to find theta. Now CD is the opposite side of theta, and BC is the opposite side of angle BDC. By sine formula, sine theta over 9 is equal to sine 97 degrees over 40. So sine theta is 9 times sine 97 degrees over 14. So theta is 39.6 degrees, correct to 3 significant figures. Next, we are going to find the length of DE. Notice that ABCD is a rhombus. Rhombus has the following properties. First one, rhombus has 4 equal sides. Second one, rhombus has all properties of parallelograms. For example, the opposite sides are parallel. Opposite sides are equal. And their opposite angles are also equal. Because AB is parallel to DC, angle DCE is equal to angle ABC is equal to 83 degrees. Besides, ABCD has perimeter 16 cm, and rhombus has 4 equal sides. So CD is equal to 16 divided by 4, that is 4 cm. So in triangle CDE, we have two angles and one side. Because DE is the opposite side of angle DCE, and CD is the opposite side of angle CED, we can use the sine formula to find DE. Sine 83 degrees over DE is equal to sine 35 degrees over 4. We have DE is 4 times sine 83 degrees over sine 35 degrees. So DE is 6.92 cm, correct to 3 significant figures. Next, we are going to find sine theta using the triangle ABD. If we can find BD and AD, we can use the sine formula to find sine theta. In this figure, we have a right-angled triangle ABC. The right-angled triangle is very useful because we can use the sine, cosine, tangent to find length or solve the angles. Also, we can use the Pythagoras theorem to find the hypotenuse. In this case, in triangle ABC, we have tangent 30 degrees is equal to 4 over BC. Tangent 30 degrees is 1 over 3. So BC is equal to 4 square root 3. Because D is the midpoint of BC, BD is equal to DC, it's equal to 4 square root 3 divided by 2, is equal to 2 square root 3. In triangle ACD, AD is square root 4 square plus 2 square root 3 square. It is by Pythagoras theorem. So AD is square root 28, it is 2 square root 7 cm. Now in triangle ABD, we have two sides and one angle 30 degrees. We can use the sine formula to find sine theta. In triangle ABD, sine theta over 2 square root 3 is equal to sine 30 degrees over 2 square root 7. Because sine 30 degrees is 1 over 2, so sine theta is 2 square root 3 times 1 over 2 over 2 square root 7. We have 3 over 2 7. Pay attention, we are finding sine theta. So do not use your calculator to find theta. So in this case, 3 over 2 7 is your answer. We can also rationalize the denominator. We multiply the surds in denominator surd 7 over surd 7. We have surd 21 over 14. This is your final answer. Lastly, we end this video by this example. When the figure is a trapezium, we will divide it into a parallelogram and a triangle, like this or this. Then we can use the sine formula to find the unknown angle or the unknown side. Go back to this example, we can draw a straight line from C to AD parallel to BA. In the parallelogram ABCE, AE and BC are opposite sides, so AE is equal to BC is equal to 4 cm. So DE is equal to AD minus AE. It is 7 cm minus 4 cm. It is 3 cm. Besides, CE and BA also are opposite sides, so CE is equal to BA is equal to X cm. Besides, angle EAB and angle ABC are interior angles, so angle EAB plus angle ABC is equal to 180 degree. So angle EAB is equal to 180 degree minus 131 degree. It is equal to 49 degree. Moreover, BA is parallel to CE, so angle DEC is equal to angle DAB is equal to 49 degree. In triangle CDE, we have two sides and one angle. We can use the sine formula to find the angle first. Notice that DE is the opposite side of angle DCE, and CD is the opposite side of the angle CED. By sine formula, sine angle DCE over 3 is equal to sine 49 degree over 4.5. Using your calculator, angle DCE is 30.20794052 degree. After that, we can find angle CDE and use the sine formula again to find CE, the unknown X. Angle EDC is equal to 180 degree minus 49 degree minus 30.20794052. It is equal to 100.792059 degree. By sine formula again, sine 100.792059 degree over XCE is equal to sine 49 degree over 4.5. So X is equal to 5.56. Okay, the answer is corrected to 3 significant figures. Next, we are going to find theta. Because angle BAE and angle BCE are opposite angles, so in this parallelogram, angle BCE is equal to 49 degree. So theta is equal to 49 degree plus 30.20794052 degree. Correct to 3 significant figures, it is 79.2 degree. So in conclusion, we can use the sine formula when the triangle has two angles and one side, or the triangle has two sides and one non-included angle. However, we can't use the sine formula in two conditions. Condition 1. The triangle is given two sides and one included angle. Take this triangle as an example. Because we don't know the angle opposite to 5, or the side opposite to angle 120 degree, we can't apply the sine formula to find the unknown theta or the unknown x. Here are the second condition. If the question only gives you the three sides of the triangle, we also can't use the sine formula because there are two unknowns. In order to find unknowns in these triangles, we have the cosine formula. So we are going to learn this in chapter 7.3. This is the end of this video. I hope you understand the sine formula and know how to use the sine formula to find the unknown sides or the unknown angles.